Today we are approximating non-perfect square roots. So we've learned that perfect square roots are numbers that when you take their square root, you get a whole number. So today we are going to be approximating square roots that when you take their square root, it's not a whole number and it's actually an irrational number, which is a number that goes on forever without repeating and without ending. So the first one we're going to look at is the square root of 53. All right, let's think about what we know about the square root of 53. So if we think about what we did before, and we look at this number line that we used in our notes the other day, I know the square root of 53 is between the square root of 49 and the square root of 64. So I know it's between the square root of 49 and the square root of 64. So it's somewhere in between there. Oops, 53. So square root of 49 is 7, and the square root of 64 is 8. So I know it's somewhere between 7 and 8. I know it's not 8 because it's lower than the square root of 64. So I know it's going to be 7 and then some change. So what we're going to do first is we're going to figure out what the rest of that is. We're going to start doing it with a fraction, and then we'll turn that fraction into a decimal to the nearest hundredth, which is 2 decimal places. So let's look at this. Let's draw a picture. We're going to draw the square root of 49. So we're going to draw a square that has an area of 49. So we're going to draw a square that has side lengths of 7. So that's a 7 by 7 square, and the area is 49. The next perfect square would be 64. So I'm just going to go ahead and draw that one. I'm going to extend it out. So the next one would be an 8 by 8 square. So I'm going to draw an 8 by 8 square. So this one's 8 by 8. So our square root is somewhere in between this 7 and this 8. So if this is 49, I'm going to count squares until I get to 53. So this is 49. So I need another one for 50, 51, 52, 53. So I have 4 out of the required 15 that I need in order to get up to my next square root. And that tells us our fraction. Since I have 4 out of the 15 that's required to get up from 49 to 64, that's going to be my fraction. So the numerator is how many over your smaller perfect square root you're at, so 4. So 7 and 4, and then the 15 comes from counting these extra ones to get you from 49 to 64. Let me write that bigger. So we have 7 and 4/15. So again, the 4 comes from how many squares you are over 49, and the 15 comes from how many squares you need, these extra squares, to get from 49 to 64. So now I'm going to take this fraction and I'm going to do long division to figure out what it is as a decimal. So 15, I'm at a 0 and a decimal. 15 goes into 40 twice, and that's 30. And that's going to give me 10, add a 0, bring it down. 15 goes into 100 6 times, and that's 90. And that gives me 10. So I should notice this is going to be repeating here. Now, when we're doing this, we are going to estimate to the nearest hundredth. So I went 2 decimal places. So if I'm rounding to the nearest hundredth, this is 2/6, and then I have to look at the third one to see, do I round or stay the same? That 6 tells me to round. So as a decimal, my approximate square root is 7.27, rounded. So in your calculator, I just want to show you that this is just an approximation. So if I were to take the square root of 53, I get 7.28. So pretty close approximation, but not exact. But that's okay, we're just approximating. And now when you're doing your assignment, you're going to use this method, not your calculator, because as you can see, your calculator is a little bit different. And so we're going to use this method instead of your calculator. All right, so let's look at another one. Let's do the square root of 40. So looking at my number line, the square root of 40 is between the square root of 36 and the square root of 49. So I know it is between 6 and 7. And I also know that it's not quite 7 because it's still less than the square root of 49. So I know my whole number is going to be 6. So let's draw the smaller square here. So area of 36, side length of 6. So I'm going to draw a 6 by 6 square. So that's my smaller square root. My larger square root is 49, so I'm going to draw a 7. I'm going to add on here to make it 7 by 7. Okay, so my square root of 40 is somewhere in between this square root of 36, or the square of 36, and the square of 49. So I'm going to start at 36 and count up 36, 37, 38, 39, 40. So I have 4 more than 36. That's going to be my numerator. My denominator is 1, 2, 3, 4, 5. Let me count that again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Because there are 13 squares that would need to be filled in order to have the square root of 49. So again, my numerator 4 comes from the extra squares I need to get 40. And then the 13 comes from how many squares I would need to add to get from 36 to 49. So now let's do 4 divided by 13. And a decimal and a 0. 13 goes into 40 3 times. And that's 39. Subtract 1, add a 0, bring it down. 13 does not go into 10, so I'm going to have to add another 0 and bring it down. 13 goes into 100 7 times, and that is 91. And we're going to stop there. You can stop when you have 3 digits, because then we can use that 3rd digit to round to the nearest hundredth. So I am going to look, my 7 is greater than 5, so I'm going to round that up to 0.31. So my approximate square root is 6.31. Okay, let's do another one, number 3. Let's do the square root of 7. So the square root of 7 is between the square root of 4 and the square root of 9. So I know it's between 2 and 3, and I know it's going to have a whole number of 2 because it's not quite 3 yet. So let me draw a square that has an area of 4, and then add on to that to make it an area of 9. So this is my 4, and the bigger one's my 9. So to get to 7, there's 4, 5, 6, 7. So I need 3 more in order to get from 4 to 7. And then to get from 4 to 9, I have 1, 2, 3, 4, 5. So it's 2 and you have 3 out of the 5 squares necessary to get from 4 to 9. So 3/5. 5 goes into 36 times, and so with the remainder 0. So we're done dividing. So it's 2.6 is our approximation. All right, next one we're going to do is the square root of 150. So looking at my number line, the square root of 150 is between the square root of 144 and the square root of 169. So it's between 12 and 13. So I know the whole number part is 12 because it's not quite 13. So I'm going to draw a square that's 12 by 12. And that is the smaller of the 2 perfect square roots. And then I'm going to draw the addition that would make it a 13 by 13 square. So if I'm at 150, right here I have 144. That's the area. So I need to go from 144 to 150. So 144, 145, 146, 147, 148, 149, 150. So that's 1, 2, 3, 4, 5, 6. So we're 12 and 6 over. How many do I need to go from 144 to 169? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So it's 12 and 6 25ths. So let's divide 6 25ths. 25 goes into 60 twice, and that's 50. Subtract this 10, add a 0, bring it down. 25 goes into 100 4 times, and it is 100. So my approximation is 12.24. Let's just check real quick, see if we are close. So the square root of 150, 12.247, so it would have rounded up to 12.25, but we were pretty close. All right, one more. Let's do the square root of 27. So the square root of 27 is between, excuse me, the square root of 25 and the square root of 36. So it's somewhere between 5 and 6. So I'm going to draw my 5 by 5 square. And then my 6 by 6 square. So it's somewhere in between those 2 squares. So to get from 25 to 27, I have to add 2 more squares. So it's 5 and 2 over. To get from 25 to 36, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 5 and 2 11ths. Now hopefully you can remember your 11ths. Remember the 11ths are multiples of 9. So if I have 2 11ths, and that's going to be the 2 times 9 is 18. So it's going to be 5.18 for my decimal equivalent. So I want you to stop and think about where we're getting these numbers from for the numerator and the denominator. Because you can continue drawing out these squares, that's fine, that's no problem. But hopefully you've caught on by now that the numerator portion is the difference between your first perfect square root and the square root that you're looking for. The difference here is your numerator. And the denominator comes from how many squares it takes to get from the first perfect square root to the second. So we're looking at the difference between the first and the last there, and that is your denominator. So if I wanted to do this without drawing a square, so say for instance I wanted to do the square root of 18 without drawing a square. So the square root of 18 is between the square root of 16 and the square root of 25. So I know it's somewhere between 4 and 5. So my whole number is 4. The numerator is the difference between 16 and 18. How many do I need to get from 16 to 18? That's 2. My denominator is how many it takes me to get from the smaller square to the larger square. So from 16 to 25, which is 9. And then I would just turn that into a decimal rounded to the nearest hundredth. All right, let's do one more. Let's do the square root of 33. So the square root of 33 is between the square root of 25 and the square root of 36. So I know it's between 5 and 6, so it's 5. The numerator is how many to get from 25 to 33, so that's 8. And the denominator is how many to get from 25 to 36, which is 11. And then 11s are multiples of 9, so 8 times 9 is 72. So our decimal would be 5.72.